Ladies and gentlemen, welcome back to the MJ's Brain Boost. And today's session, we are focusing on trying to apply what we have learned about the electrolysis. All right, especially when we're talking about the electroplating, the purification and extraction of copper. Please don't forget to like, share, comment, and hit the notification button below so that you get notified once we upload new content. So, we have in this question, it says, an attractive silver appearance can be created by electrode plating artifacts are made from cheaper metals such as nickel with silver. All right, it means nickel is cheaper and then silver is a little bit expensive. All right, so we need just a layer on top, all right, of this silver to prevent things like corrosion. All right, the simplified diagram here represents an arrangement that can be used to electroplate a nickel artifact with silver. And here we're having electrodes, electrode Y, and we're having electrode X, and then we're having silver ions solution. So then they say which electrode, cathode or anode, does the nickel artifact represent? All right, so let's remind ourselves of what we have learned. All right, if you haven't yet visited our lesson on the application of electrolysis, so you're more than welcome to do so first before you can attempt to solve these questions. All right, but we have we know that the cathode, all right, we know that the cathode, that's where you're going to have the a nickel object. All right, the cathode, that's where you're gonna have the nickel object. All right, that's where you're gonna have the nickel object. Okay, so basically that's this one. All right, so that's where you'll have your cathode. It means now this one, it will be the anode. All right. Now, it means that the correct answer here, it will be cathode. Name the metal represented by electrode Y. Remember, that's where you are in the anode. So it means the anode is what the ions that you are taking from this material, they must be attached to this one. So what are you taking? This, it means this, it's silver, and we need the silver ions to be attached to this one so that it can coat it. So it means the metal that is represented by electrode Y, it will be silver. Write down the half reaction responsible for the change that occurs at the surface of the artifact, this side. All right. So, but we know that the silver, remember, these it happens simultaneous oxidation and reduction. They happen simultaneously at the anode. All right, you're having silver. All right, you are breaking it down to silver ions. All right, breaking it down to form silver ions, and you are releasing electrons. The very same silver ions now that they were released into a solution. So remember, you're breaking this down and then you're forming these silver ions into a solution. The very same silver ions that are in a solution, they at the cathode side where reduction is taking place, they are going to be, receiving or gaining electron to give you silver like this. This will be the aqueous, sorry. This will be the aqueous. You can squeeze it in like that. So it means now here, the half reaction that is taking place at the cathode is going to be silver ion, that is the aqueous. All right, gaining that to give you the coating. So this is the coating. Give a reason why the concentration of electrolyte remains constant during electroplating. Why are they remaining constant? Because I told you that these things, they happen, a reduction and oxidation, they happen simultaneously. So it means the rate of oxidation of silver, all right, um, at the anode side, okay, is must be equal to the rate of the rate of reduction of silver ions at the cathode. All right, I hope it makes sense. But now they say in industry, some plastic articles are sometimes electroplated. Explain why plastic must be coated with graphite before electroplating. I mean, we know plastic is a non-conductor. Plastic is a non-conductor, does not conduct electricity, all right? But graphite, it will help it. Graphite, remember, it's a conductor. In geology, we have got the the machine called a secondary electron microscope, or what you call SEM, all right, and many other machines, EPMA and many other things. They need to be coated, they need to be coated with carbon first, so that charging does not happen but conductivity take place. So it's the same thing here, all right. We know that the plastic is a poor conductor, all right, or let's not say poor conductor. It does not conduct any electricity. So the plastic needs to be covered with a conducting layer, so that it can act as the cathode. So then we know that graphite is a conductor. All right. So I hope it makes sense. Give a reason why, from a business point of view, it is not advisable to plate platinum with silver. And I've already explained these materials, or these in that full lesson. All right. But silver, like platinum is much expensive, all right, and it is more durable than other metals. Yes, it's preferred, it's fine, all right, but it's very expensive. So it means you would normally electroplate a cheap metal with an expensive, a durable metal, and and a non-durable one. All right. So that's what we always think of. So I can repeat: we know that platinum is expensive and it's more durable than the other metals. All right. So in this case, um, it is not advisable to plate platinum with silver, because silver as well, it's durable, so it resists corrosion. So usually you must plate something that is cheaper with something that is more expensive, and something that is less durable with something that is more durable, or something that you could something that is less resistant to corrosion with something that is more resistant to corrosion. So silver is also less resistant to corrosion, is durable, all right, and it's a little bit or it's also expensive. So it's not as advisable to plate something that is expensive with something that is expensive. I hope it makes sense. So you must try to electroplate a cheap metal with expensive metal. So in this case, all of these things, they are expensive. Now, impure copper can be purified by the process of electrolysis. The simplified diagram represents an electrolytic cell used to purify copper. All right. So define the term electrolysis. All right. Define the term electrolysis. So electrolysis is a process during which electrical energy is converted to chemical energy. All right. It is the process in which electricity is used to bring about a chemical change. Okay. Or the process in which electricity is used up to break or to decompose compounds into its components. That's what electrolysis is. Remember, electro is electricity. Electro means electricity. Lysis means to break. So it means you're breaking the compounds. Okay, you're breaking the compounds into their components using electricity. Which electrode? All right, so but let's remind ourselves of the copper purification. Remember, copper purification is all about making you're removing impurities, making sure that now you are left with pure copper. And as you are doing that, you'll also produce what you call some sludges. All right. So in this case, you are having our solution, copper sulfate, and then you're having two electrodes, and you're having this, and then it shows that whenever you're having battery, it means you are talking about electrolytic cell. And we know that electrolytic cell, it converts electrical energy into chemical energy. All right. Before you can attempt to answer the questions, you must understand what's happening. But during copper purification, okay, during copper purification, our aim is to make sure that you are removing impurities. You are removing impurities so that you are left with pure copper. So they say which electrode P or Q consists of the impure copper? Explain how you arrived at your answer. You must know which one is the impure and which one is the pure copper. All right. So let's remind ourselves. Um, the positive terminal of the battery, it gives the electrode to be positive. So it means this electrode is positive. And the negative terminal of the battery, it gives this electrode to be negative. So this is the negative electrode. This is the positive electrode. All right. And what is a positive electrode in electrolytic cell is anode. And what is a negative electrode is cathode. And cathode, that's where reduction is taking place. And here, that's where oxidation is taking place. So in this one, we are giving off electrons. This one, we are receiving electrons. So let's think of this. Okay. The impure copper, it must be broken down. It must be oxidized. Okay. It must be oxidized so that it gives us the copper ions into a solution. So it means you must have something like this. The impure copper, it must be broken down to give us a copper ion solution, copper ions, all right, to enter into a solution so that the very same copper ions now, they can now gain electrons and then to give us more of the pure copper. I hope it makes sense. So here, that's where oxidation must take place. And here, that's where reduction must take place. All right. So it means here the idea is the impure copper must be oxidized, obviously at the positive electrode or at the anode. So it means when they say which electrode P or Q consists of the impure, you will say P. P consists of impure copper. Explain how you arrived at your answer, because P is the anode. You will say because P is the anode. And then that's where oxidation oxidation is going to take place. Okay. Because at the anode, that's where oxidation is taking place. I hope it makes sense. But Q is where is the negative cathode. All right, is the negative electrode, which is cathode. That's where reduction is taking place. And reduction, that's where you are forming a pure copper. I hope it makes sense. Now they say write down the half reaction that takes place at the electrode P and Q. Then you'll say for P and then you'll say for Q. So for P, you already know what we expecting. You have this one which is impure, it's dirty, and then you are breaking it down to give you more of a copper ions into a solution. And then in that process, electrons are released. So the electrons that are released, they are going to move. The electrons are going to move, 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 move. And then these are two electrons now in this case. These two electrons, they're going to be received by this copper 2 plus ions that were sent into a solution. So it means in this case, at the cathode where reduction is taking place, it means copper 2 plus ions that are already in the solution, they've gained these electrons to form pure copper solution or solid. All right, that is half reactions that are taking place. During purification, metals such as silver and platinum form sludge. And not only platinum, but also gold. They form sludge. Silver, platinum, all these expensive materials, they form sludge at the bottom of the container. Sludge, these are the materials which are, which are less reactive. They are inert. They do not participate more readily in chemical reaction, so they cannot be well dissolved. So they are taken off. Okay, and they fall at the bottom. Then they form in what you call a sludge. They will form at the bottom here. They form a sludge. But those that are less reactive, like zinc, that are more reactive, like zinc, they will enter into a solution. But if these materials like zinc, which are more reactive, they enter into a solution, for example, they start to pile up in the solution, then they might end up doing this. They might end up being deposited instead of us depositing copper. So you must, usually they say, you must clean these regularly. So let's refer to the relative strength of reducing agents to explain why these two metals do not form ions during the purification process. Why are they not why are they inert? All right. Why are they inert? So let's compare platinum and silver. Okay. Remember, we're explaining these things in terms of reducing agents. All right. So you'll say these two metals, silver and the platinum, they are weaker. They are weaker reducing agents than copper. So they will not be oxidized to form ions. So they will not be oxidized to form ions. It means that they will not get to be broken down to form ions. And then when they don't form any ions, and remember, for something to be in a solution, it needs to be in the ionic state. For something to be in a solution, it needs to be in ionic state. So because these two are weaker reducing agents, okay, they cannot get to be broken down to form ions that can enter into a solution. So, and we know if something is in solid state, it cannot enter into a solution. Therefore, it will settle at the bottom. So that's why the two, they will settle at the bottom as a sludge. They will settle at the bottom as a sludge. I hope it makes sense. But for copper, okay, because it's stronger, it gets to be broken down, forming more of copper solution. That's why we don't see copper as a sludge, but copper and Roma silver and many other things which are more reactive are more reactive, they will enter into a solution. Remember, silver and platinum, that's why you're usually coating with them, especially silver, for example, because they are durable and they resist corrosion. Okay. Explain why the concentration of copper sulfate solution remains constant. Interesting. Assume that the only impurities in the copper are silver. The only impurities in the copper are silver and platinum. So you assume that this, you are having silver, you are having copper, you are having platinum. All right. So these are impurities. But then the copper is what we want. So we assume that we don't have other impurities like zinc, for example. So explain why the concentration of sulfur solution remains constant. Simple. Ladies and gentlemen, you must always understand that silver and platinum, they are valuable and they are expensive. Okay? So they must the silver, they are expensive and they are valuable. All right, as much as they are sludges, but they are valuable. So let's now answer this question. All right. Like I said, if you're struggling to grab some of this content, we have explained these things deeper into that lesson. Yeah, electrolytic. All right. So we said that the oxidation and the reduction, they are occurring simultaneously, and their rate, they must be at equilibrium. So it means that the rate at which um, copper is oxidized at the anode side must be equal to the rate at which copper ions are reduced. All right. The rate at which you are forming these copper ions into a solution must be equal to the rate at which we are using these copper ions to form copper metal. Let me repeat. The rate at which you are producing, all right? I want to explain it in a simple terms without using oxidations and reduction. But what it's saying is the rate at which, let's on the two thing, all right, like that, and this, all right. The rate at which you are breaking this, remember, um, these two are only things which are valuable and they are expensive, but they are inert. So we don't expect them to enter into a solution. So in this solution, the only thing that we expect to enter into this solution is copper 2 plus. Is copper 2 plus ions. So it means the only thing that can enter here is copper 2 plus. So no zinc because we didn't say zinc. They said assume that the only thing that are present are the only these inert materials. So it means the rate at which we are forming copper ions you're forming copper ions into a solution. It must be the rate at which we are using these copper ions to form the impure copper metal, that are the pure copper metal. So the rate at which copper is oxidized at the anode side must be equal to or is equal to the rate at which copper ions are reduced at the cathode. I hope it makes sense. Why is the sludge of economic importance? In copper and silver, copper, not copper, but silver and platinum, and also gold. These materials are valuable and expensive metals, and therefore they can be after they've been collected, they can be sold at a profit. I hope it makes sense. All right. And then we are still looking at the copper purification. Look at this diagram. Refer to the diagram, the word example above. One of the electrodes consists of impure copper, and we know now, and the other one, pure copper. All right. What type of power source is used to drive the reaction in the cell? Write down only AC or DC. No, it cannot be an AC. We already said that direct current, all right, is the one that we want. So the answer, it will be the direct current, all right, not alternating current. Give a reason why the copper sulfate is dissolved in water before it is used in these cells. All right. Why are we dissolving copper sulfate in water before it is used in the cell? Before it's used in the cell. Remember, what do we want? What do we want? We want this. All right. To be for example, I think this one is, I think it's 2 minus something like this, yeah. But basically, we need free ions, all right? And we know that free ions, what do? They are needed to conduct electricity. Remember, electricity, they act as electrolyte, all right? So I hope it makes sense. When electric current passes through the solution, electrode P becomes coated. Wait. When an electric current passes through the solution, yes, electrode P becomes coated with copper. Is electrode P the cathode or anode? Support your answer by writing the half reaction that takes place at the electrode. All right. Before you can attempt to answer, try to understand what's happening. Obviously, what is coated? All right. What is coated? It's always the cathode. So it's cathode. And how do you see? All right. The this is cathode. Now it means that now this is anode. Now this will be anode. All right. So the examiner here is trying to play with your mind, because it's telling you now that you are coating electrode P, and it means this one should be the pure one. It means here you must have the pure copper. Here you must have impure in this case. So now, is electrode P the cathode or anode? Now, it's obviously that is the cathode. Support your answer by writing half reaction, because we know at the cathode we are using, it means now we've broken down the copper, all right, or we have oxidized it to give us copper 2 ions into a solution. Now, at this case, at the anode side, we are using this copper 2 plus to form the pure copper. So it means here you are going to use the 2 copper 2 plus that are in the solution with then they gain the electron to form you a pure copper. Okay, solid. This is aqueous. I always forget to write these things. I hope it makes sense. Write down the half reaction that takes place at the, okay, now it means at the anode. So anode, that's where oxidation is taking place. You are breaking it to form copper ions, plus you are releasing the electrons. Then now the electrons that are released are going to get to be transferred until they're this side, and then they're going to be received by this, and then they form this pure copper. And then where are we? It is found that the impure copper plate contains platinum. All right, it is found that the impure copper plate contains platinum. This one, it contains platinum. All right. The platinum forms a residue at the bottom of the container during electrolysis. All right, we know why, because it is durable, it does not participate in chemical reaction, does not want to be in ionic state. All right, and if it's not in ionic state, it cannot go into a solution, so it will therefore settle at the bottom. Why okay, so no, okay, so The platinum forms the residue at the bottom of the container during the electrolytes. 5. Refer to the relative strength of reducing agents to explain why platinum forms a residue at the bottom of the container. Now, I hope it makes sense because we have already covered this. All right. So you'll say that platinum is a weaker reducing agent than copper, and it will not get to be oxidized, or it will not get to be broken down to form the platinum ions. I hope it makes sense. Or you can say copper is a stronger reducing agent than the platinum, and it will be oxidized. How will the concentration of copper sulfate solution change during electrolysis? It won't change. It won't change. It will remain the same. It will remain the same because what? The rate at which we are oxidizing impure copper, it will equal to the rate at which we are reducing the copper ions to form the copper ions to form the pure copper. All right, the rate at which copper is oxidized, or the impure copper is oxidized at the anode, is going to be equal to the rate at which the copper ions in the solution are reduced at the cathode. Okay, I hope it makes sense. And then we have this one. It says in an aluminium smelter, aluminium um, aluminium metal is extracted from bauxite. Now we know that indeed aluminium oxide is extracted from bauxite, a hydrated aluminium oxide via an electrolytic process. Write down the energy conversion that takes place in an electrolytic cell. We know so far that this is different from galvanic cell, but in this case, a galvanic cell, you are producing electricity. In electrolytic, you are using electricity to give us chemical energy. So it means you will say you are using electrical energy. Electrical energy is converted into your electrical energy is converted into chemical energy. Okay, allow me to just write this. Okay, electrical energy is converted into chemical energy. Write down the equation for the half reaction responsible for the formation of aluminium metal in a smelter. Write down the equation for the half reaction responsible for the formation of aluminium metal in a smelter. Remember, good people, that when we are extracting the aluminium, remember we are having this aluminium oxide. We are having this aluminium oxide. So this one, it's having aluminium. When you're breaking it into its free ions, you'll have this and that. All right. So how can you form aluminium? Aluminium can be formed if you are having aluminium 3 plus, what am I doing? Aluminium 3 plus. Yes, like that. You have when you're having aluminium 3 plus ions, that they gain 3 electrons, and then you will form this aluminium. Right? That's how you are extracting aluminium. Okay. Explain in terms of relative strength of oxidizing agents why the electrolytic production of aluminium requires more energy than that of iron or copper. All right. Let's okay. All right. Let me check my. All right. If you go to your electrode reduction potential, or this the standard potential table, you will see that aluminium has got E cell that is minus 1.66. volts. All right? And then iron, it has got this as 0.44 volts. And then copper, it has plus 0.34. Can confirm with me from your potential table. So we need to compare these things. All right. So you will say, well, aluminium, it's more negative. All right. It's more negative. So it means it has lower reduction potential because it's more negative. So if it's having lower reduction potential, it means it's weaker oxidizing agent as compared to the this iron and this copper. So it means the aluminum ions they would need a large amount of energy to be reduced. All right. Than it was going to be than for the iron and copper. So that's why extracting aluminum is also it's always expensive. All right. Then now they say name two advantages that the use of aluminum has over that of name two advantages that the use of aluminum has over that of iron. All right. Good people, let's check. We now have aluminum windows. I think most of the modern houses they like aluminum windows and try to pick or lift those aluminum windows. They compare to the iron ones that we know. Iron ones are heavier, but the aluminum ones are weaker. So is the cars these days. The reason they very fast is because they're made up of aluminum than the olden ones which are heavy, they're made up of iron. So it means, good people, aluminium, it's lighter. Okay, so you will say, you know, the first thing you will say, where is it? You will say aluminium is lighter. All right, you will say aluminium is lighter, but lighter compared to what? Okay, so lighter compared to the iron, obviously. All right. So aluminum is lighter for the same strength. Okay. And aluminium is yo sorry. Aluminium is corrosion free. Iron, I told you that iron it gets to be easily oxidized. That's why we are having rust. All right, it gets get to be easily oxidized. If you want to experiment this, just put any iron, let it there in the rain for 2 weeks, yana. So you'll see it will get to be oxidized. It will form rust. All right, and then with time it will because it easily corrode. Okay, so aluminium it is corrosion free and it is much lighter for the same strength, obviously, as compared to iron. And then they say a huge aluminum smelter is planned for Kruger in the Eastern Cape. When operational, it will consume 1,350 megawatts of electricity, or 4% of the nation's total electricity. Mm. It is estimated that 5,200 jobs will be created at the peak of construction. It's as much as soon as we create this plant, then it means jobs will be there. About 1,000 workers will be employed on a full-time permanent basis. This is great. And between 200 and 300 full-time subcontractors will also be directly associated with the smelter. Okay, okay. Makes sense? Then they say, um, taking the present South African socio-economic realities into account, South Africa, struggling here and there, give one reason why the aluminium smelter should not be built and should be built. I mean, let's look into this. We are struggling with electricity. We are struggling with electricity. And it's taking about 4% of our nation's total electricity, or 1,350 megawatts of electricity. So it means that this, for it not to be built, it means it's taking a large amount of electricity, right? So that is the first disadvantage, right? But on the advantageous part of things, it's good because you see, it's creating jobs. It's giving us a lot of jobs. So as much as it will take a lot of electricity, but at least it's giving us jobs. Give one reason why environmental activists oppose the construction of the smelter. All right. So this is because we are the using a lot of electricity. All right. We are using a lot and lot of electricity. That could be the first thing. And then what another thing? Pollution. The problem will be pollution. The problem, it will be pollution. Another problem, it will be it's consuming a lot and lot of electricity. All right. And another problem could be the climate change. Could be the climate change. All right, because it will cause greenhouse gases. All right, it will deteriorate our ozone layers. All right, causing the greenhouse effect. All right, such as global warming. All right. So I hope it makes sense. So this will bring us to the end of our lesson on solving the electrolytic cell equation. If you have any issues, you're struggling to understand some of the concept, you are more than welcome to comment on the comment section, and I'll be pleased to assist. And you know what I'm about to say. Until next time, cheers.